welcome. Today's topic is simulated annealing and Boltzmann machine. So the basic concept of simulated annealing is motivated by the annealing concept in solids. So if a metal is heated well above the melting point and it is cooled suddenly, its structural properties will change depending on the rate of the cooling. The same way is used for machine learning. So simulated annealing is a stochastic computational method inspired by annealing. The algorithm goes in this way. Step 1, generate the random solution. Calculate its cost using some cost function. Generate the random neighboring solutions. Calculate the new solution cost by the same cost function and compare the cost of the new solution with the old one. If the new solution cost is less than the old one, then move this as the new solution. If not, proceed with the old solution as the cost. Test for stopping criterion, which may be the maximum number of iterations has reached or get an acceptable solution. The next today's topic is Boltzmann machine. They are stochastic learning process having recurrent structure, which means all neurons connected to every other neurons. It's used for optimization in artificial neural network. It was invented by Geoffrey Hinton and Terry Sanjowski in 1985. It was only locally available information. The change of the weights depends on the behavior of two units it connects, though the charge optimizes in the global machine. It uses recurrent structure. The two possible states are maybe either of state 0 or 1. Some of the neurons in this are adaptive free state and some are in clamped frozen state. So when we apply the simulated annealing on discrete Hopfield network, then it would become a Boltzmann machine. It's used for an optimization of the problem. So the architecture is in this way. So we have all the neurons here, U11, U1j up to U1n, UI1 up to UIN, UN1 up to UNN. And every neuron has a self connection with weight B. Every neuron is connected to the other neuron with a weight minus P. See here, every neuron is connected to the other neuron with weight minus P and self connection weight is B. So it's a two-dimensional array of units. Weights on interconnection between the units is minus P, where P is greater than 0. Self connection weights is B. The no training is required in Boltzmann machine as we have fixed weights. This P and B is not going to change, so there is no requirement for training here. Weight has to find the consensus function CF. UI and UJ has bidirectional connections. Wij is not equal to 0 if UI and UJ are connected. So if two neurons are connected, the weight between the neurons is not equal to 0. There exists a symmetry in the weight connection, which means Wij equal to Wja. So it is bidirectional, as you can see in the diagram. And then Wia is the self weight which also exists. The consensus function CF is equal to sigma Wij Ui Uj. When the state changes from 1 to 0 or 0 to 1, change in consensus function del CF is 1 minus 2 Ui into Wij plus sigma Ui Wij. Ui is the current state of Ui. So Ui equal to 1 if Ui is currently on and it is minus 1 if it is currently off. Probability of the network to accept the change in state is AF of 1 by t equal to 1 comma t is 1 by 1 plus x power minus del CF consensus function of I by t, where t is the control parameter. In the testing algorithm, initialize the weights and the control parameter t, randomly choose INJ, calculate the consensus function change and calculate AF of I comma t. Accept if R is less than AF, then accept the change. If the random number which we have taken is greater than or equal to AF, reject the change. And the T new equal to 0.95 into T old. Step for test for stopping condition, T new is 0.9. The stopping conditions are temperature reaches a specified threshold value. There is no change in the state for a specified number of continuous iterations. And if stopping condition is not satisfied, continue in step 2. So this is regarding